Dear students, welcome. Today we will study and verify mesh analysis. Let's proceed to our lecture. First of all, we will define what is mesh analysis and what it is used for. The mesh analysis is a technique or method that is used to solve planar circuits for the currents at any place in the electrical circuit. The planar circuits are such circuits that can be drawn on a plane surface with no wires crossing each other. The planar circuits are the simple circuits, whereas there is a more general technique known as loop analysis that can be applied to any circuit, whether planar or not. In mesh analysis, the currents flowing through each mesh are considered. So here, first you need to know what is mesh, and after that you need to know what is a branch and different associated terminologies. Therefore, the mesh analysis is also known as mesh current analysis or mesh current method. This is due to the fact that in mesh analysis we are dealing with measurement of currents within a mesh. First of all, let's define what is a branch. A branch is a path that joins two nodes and it contains a circuit element. For example, within a mesh, there is a point where a resistor is connected. So the resistor is basically joining two different nodes. So that is a branch. If the branch belongs to only one mesh, then the branch current will be equal to the mesh current. Whereas if the branch is common to two meshes, then the branch current will be equal to the sum or difference of the mesh currents when they are in the same or in opposite direction. There is a specific procedure to be followed in order to do the mesh analysis. Therefore, the following steps should be followed while solving an electrical network or a circuit through mesh analysis. Step 1. You have to identify the meshes and then label those meshes with its currents in either clockwise or anti-clockwise direction. Well, most probably clockwise direction is taken, but you can also consider the anti-clockwise direction. The step 2 is observing the amount of current that flows through each element in terms of mesh current. That is, you have to observe the amount of current which flows through each and every resistor that is connected in the mesh current. The step 3 is to write mesh equations for all of the meshes. The mesh equation is to be obtained through application of KVL and Ohm's law. The step 4 is solving the mesh equations that are obtained in step 3 for getting the mesh currents. When you get the mesh equations, then you have to interpret those equations. You have to find the values of all currents that are existing within these meshes. Now we can find that the current and voltages flowing through or across any element that is present in the given network by using mesh currents. As I already mentioned, element is either resistor or any other component which is connected in the circuit. Let's move to our example. Consider the given circuit. It has two voltage sources, one of 20 volts and the other of 80 volts. Three resistors are connected, 5 ohms, 10 ohms and 30 ohms. As mentioned in the procedure, the first step is to identify the meshes in the circuit. Here we have two meshes. So we have to define the direction of the current. The direction of current is taken as clockwise in both meshes. So we have the mesh currents in the form of I1 and I2, and the direction is considered as clockwise as mentioned already. The mesh current I1 flows through 20 volt source and 5 ohm resistor. Similarly, the mesh current I2 flows through 30 ohms resistor and 80 volts voltage source. But the difference of these two mesh currents I1 and I2 is flowing through 10 ohms resistor. You can see this resistor is connected in between these two meshes. So this resistor is known as branch, and I1 and I2 both are passing through this resistor. If we consider the currents of I1, or let's say if we consider KVL through mesh 1, then it will be like 20 volts minus IR1 minus I1 minus I2 multiplied by this resistance. Similarly, if we consider second mesh, then we will consider I2 minus I1 multiplied by 10 ohms plus I2 multiplied by 30 ohms resistor is equal to 80 volts. This is how you will calculate, or you will equate Kirchhoff's voltage laws equation for both these loops. As I already mentioned, 10 ohm resistor is the common branch among the two meshes. So we get two mesh equations since there are two meshes in the circuit. When writing the mesh equations, assume that the mesh current of the particular mesh is greater than all the other mesh current of the circuit. The equation for the first mesh is as follows: 20 volts minus 5I1 minus 10 into I1 minus I2. You see, I already mentioned that if there are two currents passing through a single component, then it will be written in the form of sum or difference. Here we have difference. This equation is simplified as 20 minus 15I1 plus 10I2. We have 10I1 here and 10I2 here. So we have minus 15I2 plus 10I2. It can be written as 10I2 is equal to 15I1 minus 20, which can further be divided by 5. So we get 2I2 is equal to 3I1 minus 4. Now the equation for mesh 2 can be written as follows: minus 10I2 minus I1 minus 30I2 plus 80 is equal to 0. Now here we have difference of I2 minus I1. because we consider the mesh current I2 to be greater than mesh current I1. And then we have 30 ohms resistor and I2 and 80 volt source. The equation can be simplified by dividing it through 10. We get minus I2 minus I1 minus 3I2 plus 8 is equal to 0. It can be written as minus 4I2 plus I1 plus 8 is equal to 0. In the final form, this equation can be written as 4I2 is equal to I1 plus 8. Multiplying the equation of mesh 1 with 2, we multiply this equation with 2, so we get 4I2 is equal to 6I1 minus 8. Now we can find the current I1 and I2 by solving the equation 1 and equation 2. The left hand side of equation mesh 1 and mesh 2 are the same. That is 4I2 is here and 4I2 is here as well. So equating the right hand side, the terms of equation mesh 1 and equation mesh 2 in order to find the value of I1, we get 6I1 minus 8 is equal to I1 plus 8. So we get 5I1 is equal to 16. We move 8 to the right hand side and I1 to the left hand side. This will become positive at right hand side and I1 will become negative at left hand side. So we have 5I1 is equal to 16, which can be written in the form I1 is equal to 16 by 5, which is equal to 3.2 amperes. So I1 is found to be 3.2 ampere. We move on to find I2. For that we substitute I1 value in equation of mesh 2. So we will get 4I2 is equal to 16 by 5 plus 8. 4I2 is equal to 56 divided by 5. I2 is equal to 14 divided by 5. So the value of I2 is 2.8 amperes. Here we have 2 points to be noted. The point 1 is, from the above example, we can conclude that we have to solve M mesh equations if the electric circuit is having M meshes. It means that if certain circuit has 7 meshes, so we have to solve 7 mesh equations for this respective circuit. So this is why we can choose mesh analysis when the number of mesh is less than the number of principal nodes except from the reference node of the electrical circuit. The point 2 to be noted as, we can choose either nodal analysis or mesh analysis when the number of meshes is equal to the number of principal nodes except from the reference node of the electric circuit. Let's move to the simulations. We'll go to falstad.com/circuit for simulation of the circuit so that we may be able to verify mesh analysis. See you in the falstad simulator. Here we are at the falstad simulator. First of all, we will clear the screen. So we will go to circuits and check on the blank circuit. Now we will start building our circuit, which had 3 resistance and 2 voltage sources. Remember that one of the voltage sources was negative, that was connected to the right side of the circuit. Now we will change the values of the resistors. First resistor was of 5 ohms, second resistor was of 10 ohms, and third resistor was of 30 ohms. We will connect the circuit together. I will connect it like this through wires because later we have to add ammeters here for verification of the circuit. We should not add any wire here, so we just place one wire here and the other wire here. Now the circuit is almost complete. We have to place two voltage sources. We go to draw, input, sources, and place two voltage sources. The first voltage source is positive, so we will make it sure that its positive side is above and negative side is below, and we change it to 20 volts and click on OK. And the other voltage source was negative, so its negative side will be above and positive side will be below. Let's change its value to 80 volts. Now the circuit is complete, else that we have to add ground and we will place it right here. Now we see that here is our first loop and this is our second loop. As mesh analysis is for finding the currents of the circuit, but here we will verify the voltages and current both. So first we will place voltmeters on the respective resistors and check whether KVL is verified. If KVL gets verified for the meshes, then it means that the mesh current will be exactly the same that we found during our calculation. So let's go to draw, output and labels, and we will place 3 voltmeter for verification of voltages. Remember that here we have negative voltage, so we will place the voltmeter and reverse polarity when compared to the other 2 voltmeters. So then we connect the voltmeters with the resistors through wires. This is not connected, so we will connect it properly. Now this is properly connected and we have 16 volts drop here. We will connect the other voltmeter. We have 4 volts drop here. Now if we compare the first mesh, here we have 20 volt source. So first resistor consumes 16 volts and the other resistor consumes 4 volts. So in this mesh we have conservation of voltage, that is 20 volt is drawn equally by both these resistors. That is, when we add 4 and 16 volts, it becomes equal to 620 volts, which is the source voltage. Now we will connect this voltmeter to this resistor to know what is the voltage here. Now taking this mesh in clockwise direction, we can see that we have 4 volts drop here, plus 4 volts drop here, and minus 84 volts drop here. So when we add both, we get minus 80 volt, which is exactly the source voltage. So it means that KVL is get verified for both of these meshes. Now what we will do is to place ammeter right here and here. The ammeter will be placed here at both these points because we have two currents here. This will be the current, this point will be the current of mesh 1 and this point will be the current of mesh 2. So let's delete these wires and place ammeters here and check whether we get exactly same amount of current that we calculated or not. So we go to draw, output labels, and click on add ammeter and we place ammeters here. You can see we get 3.2 amperes here, which is exactly same that we calculated for I1, and we get 2.8 ampere here, which is exactly the same that we calculated for I2. Here we can say that the simulation is verifying the mesh analysis because we are getting the same results that we deduced during our calculations. As we are done with the simulation now, it's time for your home task. You have to verify mesh analysis for the circuit given below. You need to do the calculations as well as simulations. This is the circuit. Here you have two voltage sources, both of 15 volts. Consider this as 15 volts as well. So you have 2K here, 2.1 kilo ohm here, 1 kilo ohm here, 2 kilo ohms here, and 1.9 kilo ohms here. There are 3 loops or meshes and 1 major mesh. So you have to verify mesh analysis for this circuit. This was all about today's lecture. If you have any queries or questions you may ask, you can email it to me or post it directly here. Best of luck. See you in the next lecture.